In a world where the laws of physics seemed set in stone, a simple yet perplexing experiment in the early 20th century posed a challenge to the established understanding. This experiment would lead to a groundbreaking revelation, one that reshaped our understanding of the universe at its most fundamental level. How did a straightforward setup involving light and metal lead to one of the greatest scientific discoveries of all time? The beginning of this story takes us to a seemingly mundane laboratory setting. The stage was set with a simple apparatus, a piece of metal and a source of light. The goal? To observe how electrons react when light is shone upon metal. Scientists expected a straightforward outcome, adhering to the classical view of light as a continuous wave. However, the experiment unveiled something entirely unexpected. As the light hit the metal, electrons began to be emitted, a phenomenon known as the photoelectric effect. But the behavior of these electrons defied classical expectations. According to the wave theory of light, the energy of the electrons should gradually increase with the intensity of light, eventually causing them to be ejected from the metal. But the experiment showed otherwise. Only light above a certain frequency could eject electrons, and their energy was not dependent on the light's intensity. This puzzling observation stood in stark contrast to what the wave theory of light would predict. Enter Albert Einstein. With an uncanny ability to see beyond the apparent, Einstein pondered this conundrum. His solution was both elegant and revolutionary. He proposed that the light was not just a wave, but also composed of discrete, invisible packets of energy. These packets, later known as photons, were the key to understanding the photoelectric effect. In Einstein's view, the energy of these photons was linked to the frequency of light, not its intensity. This radical idea suggested that light had a dual nature, acting both as a wave and as a particle. Einstein's insight was a cornerstone in the burgeoning field of quantum mechanics. The concept of photons challenged the classical understanding of light and opened the door to a new quantum universe. It suggested that at the most fundamental level, our universe was governed by principles that were radically different from our macroscopic experience. Photons, as invisible units of light, demonstrated that energy in the quantum realm was quantized, existing in discrete amounts rather than as a continuous spectrum. Einstein's hypothesis of the nature of light had far-reaching implications. It wasn't just a solution to the photoelectric effect, it was the fundamental shift in how we perceive the universe. This insight laid the groundwork for the development of quantum mechanics, a field that would revolutionize our understanding of everything from atomic structure to the behavior of materials at the nanoscale. The concept of quantization, initially applied to light, would soon be found to be a universal property of the quantum world. Einstein's contribution to the quantum theory, particularly his work on the photon, earned him the Nobel Prize in Physics. But perhaps more significantly, it cemented his role as one of the most influential figures in the history of science. His work on photons was just one of many groundbreaking contributions, but it holds a special place as it marked the beginning of a new era in physics. It was the first clear evidence that entities, previously thought to behave strictly as waves, also had particle-like properties. The story of Einstein and the photon is more than just a historical footnote. It is a testament to the ongoing journey of scientific discovery. It reminds us that our understanding of the universe is always evolving, shaped by new insights and discoveries. As we continue to delve deeper into the quantum world, we build on the foundation laid by Einstein and others, pushing the boundaries of what we know about the nature of reality. Einstein's insight into the dual nature of light was a pivotal moment in the history of science. It challenges us to think beyond the apparent, to question our assumptions, and to remain open to the endless possibilities of discovery. How will our understanding of the universe continue to evolve as we uncover more secrets of the quantum realm? Give us a like if you believe in the limitless potential of space exploration. Subscribe to stay updated with our latest missions and discoveries. And most importantly, leave your thoughts. Tell us what you feel about this new age of exploration and how you envision the future.